Hi all, let's generate a sawtooth waveform by writing an assembly language program. So let's write an ALP program to generate a sawtooth waveform in 8085 microprocessor. So what is a sawtooth waveform that we have to know? So when you say sawtooth waveform, you have a gradual rise or a fast decay, gradual rise, fast decay, or a fast rise, gradual decay. So sawtooth waveform can be generated in any way. Now let's look into that how we can do it. It's the same logic what we have used in last video for square waveform. In the same way here also, same references. So we can start from maybe this starts at -5 volts and ends at +5 volts. So either this type of waveform or this type of waveform. Let's see. So we'll start from -5 volts. So we'll generate it like this. So -5 volts. A slow rise and a fast decay. Fastest decay. It's not like a triangular wave, it's a sawtooth wave. So slow rise, then a fast decay. Slow rise, fast decay. Let's write a program for that. So we say that MVI A comma 0 0. So let's say that we say that MVI A comma 0 0. So what is that MVI A comma 0 0? So 0 0 is a reference. It's equal, its value is -5. That means you're starting at -5 volts. So let's start at -5 volts. And then we have to out that value, out C naught. I'm sorry, out C naught. So C naught is a port address, so you're outing that value, so it comes and stays here. It comes and stays here. After that, there's a slow rise. So you have to increment the value. It's a slopey rise. So you're incrementing your accumulator content. So maybe here you'll increment, after that, here it goes, after that it goes. Like that, it keeps incrementing. So finally, you have to compare with the reference. After incrementing, you have to compare with some maximum value. Let's say that is your plus FF. That is your FF plus 5 volts. So you're comparing with FF. So once it is equal to FF, you have to stop it. Till that time, you have to keep on incrementing. So increment A, compare with FF. So first increment, compare with FF. Second increment, compare with FF. So once it comes here, it is equal to FF. Till that, you have to increment. So that you get a slow rise. And once it is compared, you have to check for, once it is equal to FF, you have to check for the 0 flag. Jump if not 0. So if it is not equal to FF means, if the current value is not equal to FF means, you have to go to the loop. So there's a loop here. So loop, I call it as L2. That means what? Out that value. So once you increment, out that value. Compare with FF. If it is not equal to FF, again increment, go to next value, out that value. Out that value, then only it will come and stay in that line. Stay in that point. Again increment. So till it reaches your FF, you have to keep on incrementing from 0 0. That is equal to -5 volts. So once it is equal to FF, a 0 flag will be set. If it is not equal to 0, keep on incrementing. Once it is equal to 0, what we're supposed to do that, we have to out that value. We have to out that value through the port address C0, out C0. So that's what here. So it will come and stay here. So you have generated a slope here. You have generated a slope. So I can draw the slope in this way. So you have generated a slope here. That is your slope. So a slow rise. It is generated now. Now you have to go for a fast decay. After outing that value, you have to go for a faster decay. So what you do? Jump to start. So you give it as jump to start. So what is that start? This is your start. This is your start. What do the start say? MBI A, 0 0. That means what? So you have come here, again go to -5 volts. So it comes here. So after that, out that value. So this value will be outed. Again, keep incrementing. The next increment starts. Increment, and compare with FF. So it keeps comparing with FF. Again, the logic again starts till it comes to 0. When it comes to that point, it is equal to 0 flag. So till it comes to 0 equal to ff, it keeps on incrementing. You have to keep on incrementing. That's what. So increment again, out that value. Again jump to start. Once it reaches ff, jump to start. So the logic keeps on repeating and you get a repetitive sawtooth. I hope you have understood. It is very simple. You're starting at this point. Again, you keep incrementing. So this is your maximum reference ff, and then it comes to start point. Again, you increment. Again, it comes to start point. Again, you're incrementing. Again, it comes to start point. So this process repeats, and this is how a sawtooth waveform is generated. This is how a sawtooth waveform is generated in 8085 using an ALP program. Thank you all.